أعزائي طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج ديناميكس. النهاردة إن شاء الله عندنا حلقة المراجعة النهائية. Dear students of grade 3 secondary, welcome to our math program. Today we have dynamics. Our lesson today is final revision. A particle moves in a straight line such that the algebraic measure of its velocity v is given as a function in time t with the relation v equals 6t power 2 minus 24, where v is measured in meter per second. The first required: find the magnitude of the acceleration of the particle when its velocity becomes 30 meters per second. The second required: find the magnitude of the displacement during the time interval t belongs to closed interval 1 and 4. Now we have v, the algebraic measure of velocity, equals 6t power 2 minus 24. The derivative of the velocity with respect to time is the acceleration. Then a equals dv dt. The derivative of 6t power 2 equals 12t, and the derivative of negative 24 is 0. Then the acceleration equals 12t. Now, what is the magnitude of the acceleration of the particle when its velocity becomes 30 meters per second? When v equals 30 meters per second, then 6t power 2 minus 24 equals 30. 6t power 2 equals 30 plus 24, which equals 54. Then t power 2 equals 9, and t equals 3 seconds. Then the acceleration after 3 seconds equals 12 multiplied 3 equals 36 meters per second squared. Now, what about the displacement? We know that the velocity v equals dx dt. Then dx dt equals 6t power 2 minus 24. We can find the integral of both sides. Definite integral dx from x node to x equals definite integral 6t power 2 minus 24 dt from 1 to 4. What about the integration of dx? Integration of dx equals x from x node to x. And the integration of 6t power 2 minus 24 is 2t power 3 minus 24t from 1 to 4. We can substitute the left hand side x minus x node equals the right hand side 2 multiply 4 to the power 3 minus 24 times 4 minus 2 multiply 1 power 3 minus 24 times 1. The left hand side x minus x node equals the displacement s, and the right hand side equals 54 meters. Then the displacement during the time interval t belongs to closed interval 1 and 4 equals 54 meters. Another exercise. A body of mass 3 kilogram is let to fall from a height of 10 meters on a sandy ground to sink embedded in it for a distance of 5 centimeters. Find the sand resistance to the body in kilogram weight, given that the body moves with a uniform acceleration within the sand. Now we have body fall from a height 10 meter, then the motion in this case is free fall. The mass equals 3 kilogram. The initial velocity v node equals 0. The displacement s equals the height from the ground equals 10 meter. Now we can use the relation v squared equals v node square plus 2gs to get the velocity. V squared equals 0 plus 2 multiply 9.8 meter per second squared multiply s, which equals 10 meter, then v squared equals 196. The magnitude of the velocity equals 14 meter per second. Now, when the body moves in the sandy soil, the mass of the body equals 3 kilogram. Its initial velocity 14 meter per second, and the final velocity equals 0. The distance in the sand equals 5 centimeter, which equals 5 over 100 meter. Now we can use the relation v squared equals v node square plus 2gs. The acceleration in this case equals a. Then 0 equals 14 power 2 plus 2 multiply a multiply 0.05. 0.1 times a equals negative 196. Then the acceleration equals negative 1960 meter per second square. About the motion of the body in the sandy soil, we have Newton second law, ma equals mg minus r. mg, the weight of the body, and r is the resistance of soil, sandy soil. The mass equals 3 kilogram, multiply the acceleration, which equals negative 1960, equals 3 multiply 9.8 meter per second square minus r. Then r equals 3 multiply 9.8 plus 3 multiply 1960. Then the resistance equals 5909.4 Newton. Take care. Now, what is the resistance in kilogram weight? The resistance in kilogram weight equals 5909.4 Newton divided 9.8. Then the resistance equals 603 kilogram weight. Another exercise. The opposite figure shows a body at rest and a system of forces acting on it. Then F1 plus F2 equals 0, equals 20, equals 50, or equals 120. Dear students, since the body is at rest state, then the vertical forces are in equilibrium. Then F2 plus 40 equals 90. F2 equals 90 minus 40, then the magnitude of F2 equals 50 Newton. And the horizontal forces are in equilibrium. Then F1 equals 20 plus F2. F2 equals 50 Newton. Then F1 equals 20 plus 50, which equals 70 Newton. F2 equals 50 Newton. F1 equals 70 Newton. Then F1 plus F2 equals 70 plus 50, which equals 120 Newton. and we can choose letter D. Then F1 plus F2 equals 120 Newton. Another exercise. A body of mass 20 kilogram is suspended in a hook of a spring balance fixed in a balloon. Then the apparent weight of the body if the balloon is descending with uniform deceleration equals 4.9 meter per second square equals 10 kilogram weight, 30 kilogram weight, 40 kilogram weight, or equals 294 kilogram weight. Since the balloon is descending with uniform deceleration equals 4.9 meter per second square, then A equals negative 4.9 meter per second squared. And the apparent weight T equals M multiply G minus A. G minus A because the balloon is descending. T equals the mass of the body, which equals 20 kilogram, multiply G 9.8 meter per second squared minus negative 4.9 meter per second squared. T equals 20 multiply 9.8 plus 4.9. 9.8 meter per second square, 4.9 meter per second squared. Then T equals 20 multiply 14.7, which equals 294 Newton. Now the apparent weight in Newton. What is the value of T in kilogram weight? T equals 294 divided 9.8 equals 30 kilogram weight. Then the apparent weight equals 30 kilogram weight. And we can choose letter B from the choices. Another exercise. If a body moves on a smooth inclined plane and inclines with an angle of measure theta under the action of its weight only, then its acceleration of motion is equal to G cosine theta, G sine theta, or equal 0. We have a body moves in a smooth inclined plane inclined with an angle of measure theta under the action of its weight only. The weight of the body mg vertically downward. We can resolve this force into perpendicular component mg sine theta in the direction of the line of the greatest slope downward, and mg cosine theta perpendicular to the line of the greatest slope downward, and the normal reaction n. The direction of motion downward. Then from Newton's second law, the equation of motion is ma equals mg sine theta. We can divide both sides by m. Then the acceleration A equals g sine theta. And we can choose letter C from the choices. Another exercise. A body of mass 12 kilogram is placed on a rough horizontal plane if the coefficient of the static friction between the body and the plane is equal to √3/3, whereas the coefficient of the kinetic friction is equal to root 3 over 4. Then calculate the magnitude of the force which make the body about to move. Then calculate the magnitude of the force which make the body about to move and find the magnitude of the force which makes the body move with an acceleration of magnitude 49 root 3 over 20 meter per second squared. Knowing that the force inclines at 30 degrees to the horizontal. Now we have a body of mass 12 kilogram placed on a rough horizontal plane. The coefficient of static friction mu s between the body and the plane equals root 3 over 3, and the kinetic friction mu k equals root 3 over 4. And we have a force F inclined to the horizontal by an angle of measure 30 degrees upwards. We can resolve the force F into perpendicular component. The first component, F cosine theta, parallel to the plane of motion, and the second component, F sine 30, perpendicular to the plane of motion. We have mg vertically downward, the weight of the body, and we have the normal reaction in perpendicular to the plane vertically upward. When the body about to move in the direction of the component F cosine 30, the friction force appear and its direction in the opposite direction of motion. Now, first, the force makes the body about to move. We know that N plus F sine 30 equals mg. N plus F multiply sine 30 degree equals half. N plus half F equals 12 multiply 9.8. Then the normal reaction N equals 12 multiply 9.8 minus half F. And F cosine 30 equals mu S N. Cosine 30 degree root 3 over 2 multiply F equals mu S equals root 3 over 3. Multiply between two bracket 12 multiply 9.8 minus half F. Multiply both sides by 6 over root 3. Then the left hand side 3F equals 2 multiply between two bracket 12 times 9.8 minus half F. Then 3F equals 24 times 9.8 minus 2 multiply half F equals F. 3F plus F equals 24 times 9.8. Then 4F equals 24 multiply 9.8. Then F equals 6 multiply 9.8 Newton. We can divide by 9.8 to get the magnitude of the force in kilogram weight unit. Then the force makes the body about to move equals 6 kilogram weight. Now the second case. The force moves the body with an acceleration of magnitude 49 root 3 over 20 meter per second squared. Now N plus F sine 30 equals mg. N plus half F equals 12 multiply 9.8. The normal reaction N equals 12 times 9.8 minus half F. What about the equation of motion? From Newton's second law, MA equals F cosine 30 degrees minus mu Kn. The mass of the body equals 12 kilogram multiply the acceleration 49 root 3 over 20 meter multiply cosine 30 which equals root 3 over 2f minus mu k. Mu k equals root 3 over 4 multiply between two brackets the magnitude of the normal reaction n which equals 12 times 9.8 minus half f. Divided both sides by root 3, then 12 multiply 49 over 20 equals half f minus quarter multiply between two brackets 12 times 9.8 minus half f. The left hand side 12 times 49 over 20 equals half f minus quarter multiply between two brackets 12 times 9.8 minus half f. 12 multiply 49 over 20 in the left hand side equals half f minus 3 times 9.8 minus 1 over 8 f. We can use the calculator to find the value of the force F which equals 94.08 Newton. We can divide it by 9.8 to get the magnitude of the force in kilogram weight. Then the magnitude of the force moves the body with an acceleration of magnitude 49 root 3 over 20 meter per second square. The magnitude of this force equals 9.6 gram weight. Another exercise. The forces vector F1 equals 4I minus 3J plus K, vector F2 equals I plus 2K, and vector F3 equals 4J minus K act on a body for a time interval of magnitude 5 seconds. Find the magnitude of the force impulse if the magnitude of the forces is measured in Newton unit. We have three forces. The resultant of these forces F equals vector F1 plus vector F2 plus vector F3. Vector F equals 4I minus 3J plus K plus I plus 2K plus 4J minus K. Then the resultant of these forces F equals 5I plus J plus 2K. What about the impulsive force? Impulsive force I equals vector F multiply time T. Then I vector equals 5I plus J plus 2K multiply 5. I equals 5I multiply 5 which equals 25I plus 5J plus 2K multiply 5 equals 10K. Now we have the impulse as a vector. What is the magnitude of the impulse? I equals norm vector I. Norm vector I equals square root 25 power 2 plus 5 power 2 plus 10 power 2. Then the magnitude of the impulse I equals 5 root 30 Newton second. Another exercise. The opposite figure represents the force time graph. Then the magnitude of the impulse of F within the time interval closed interval 0 to 5 in Newton second equals. The impulse equals, we know that the impulse equal the change of momentum. Change of momentum or equal the area under the curve. Now we have the area under the curve from t equals 0 to t equals 5 is the area of a trapezium. We know that the area of trapezium equals half the sum of the two parallel bases multiply its height. Then equals 12, 16, 20, or equals 25 Newton second. Now I equal the change of momentum equals the area under the curve. The area under the curve equals the integration of f dt from 0 to 5, which equals the area of the trapezium half between two bracket P1 plus P2 multiply the height h. I equals half multiply the sum of the two parallel bases. The first base equals 5 and the second equals 3 between two bracket multiply the height, which equals 5. Then the impulse I equals 20 Newton second, and we can choose letter C. بكده أعزائي نكون راجعنا مع بعض أهم دروس منهجنا السنة دي في الداينامكس، وعرفنا ازاي نتعامل مع نوعية أسئلة الام سي كيو اللي هي الاختيار المتعدد. كمان عرفنا ازاي نتعامل مع الأسئلة المقالية اللي هي فيها سؤالين من الأسئلة المقالية في الامتحان. أخيرا لكم مني ومن أسرة البرنامج كل الدعوات بالنجاح والتوفيق، والسلام عليكم ورحمة الله وبركاته.